The building of a cathedral in the 11th century was a colossal undertaking.
All around me here would have been perhaps a couple of hundred people working in what would have looked like a small town. The noise and dust must have been extraordinary. The smoke and sparks of a blacksmith's forge, the buzz and rasp of carpenters' saws, stone dust thick in the air as the masons cut and carved and polished, and people shouting at each other in French, English, even Latin. The din must have been deafening.
Stage 1 was to lay the foundations.
We're actually under the east end of Norwich Cathedral. This is where construction of the church itself started. Firstly, they would have to dig foundation trenches within which they would put the local stone, and the local stone in Norfolk is flint. Because they're using small flints, they would use very large quantities of burnt lime. There's a lot of chalk in Norfolk. They can burn the chalk to make lime, and mixing it with water and sand to create a mortar to hold the whole wall together. In order to get it as true as possible, because they're building in flint, will be built between shutters, wooden panels, if you like, which would be put in at a height of about 1/3 of a metre or thereabouts. You can see that surviving in the walls because the smoothness of the walls, particularly here, can only be attributed to the fact that the panelling, the shuttering was there as part of that construction process.
Building usually started at the east end, where Mass was celebrated. When that was finished, the church could be consecrated and put to use, followed by the transepts, running north to south. The nave and the side aisles would follow. From foundations to finish might take less than 60 years, or as many as 200 if the money ran out.
It's a bit of a myth that the medieval cathedrals somehow designed themselves in a great communal outburst of religious energy without the help of what we would call an architect. In fact, he may not have been called an architect, but to create a structure of this ambition, you needed a man with skill, vision, and expertise, a man who knew what he was doing.
Those men were called master masons. They learned everything they knew on site, progressing from apprentice to stone carver. They travelled and made sketches of what they saw, adapting them for their own designs to put to the bishop. Very few medieval masons' plans or notebooks survive. Those that do show they knew geometry, not the theory that we understand today, but a geometry based on the complex manipulation of squares, circles and triangles to produce shapes and patterns in regular proportions.
Some of these patterns can seem pretty sophisticated. The ratio of 1 to the square root of 2, for example, crops up in lots of cathedrals. It's a formula that suggests some pretty sophisticated mathematics. In fact, it's very easy to generate using some basic geometry. Simply draw a square and then draw a diagonal across it, and the relationship between the diagonal and the side of the square will be in the proportion of 1 to the square root of 2. So if you take the ground plan or footprint of a cathedral like Norwich, for example, the cloister is a square. Draw a diagonal across it, and you get the length of the nave. Create a square from that length, and a diagonal across that square gives you the length of the entire church, right up to the high altar.
proportion, ratio, symmetry. To the medieval mind, these were spiritual qualities. They reflected the harmony of creation, and medieval masons cared passionately about them. Some have claimed to spot mysterious messages and codes in the dimensions of medieval cathedrals. The number 144, for example, which refers to the number of those who will be saved in the book of Revelation.
All kinds of numbers that occur in the Bible pop up from time to time in cathedral architecture. These are mostly the ideas of churchmen. Much more common are the basic geometrical principles followed by the master masons. With a square and a circle and a diagonal, you can generate an entire cathedral. But how much hard science did the architect know? The knowledge of mathematics, physics, and engineering that we take for granted today. These are the things that would make a building like this stand up or fall down.
The master masons really understood stability, centre of gravity, and where that centre of gravity would be in their piles of stones that eventually make a full cathedral. They would have not understood the concept of stress. That is a modern concept. It's the intensity of load. It's how much load per unit of area. And in a cathedral like this, that intensity of force is really comparatively low. It's about 100 tons on every square metre. So if you think of these columns as 1 square metre by 1 square metre, they could easily carry 100 tons. Indeed, they could carry 1,000 tons. Those columns in the nave are huge, and they are the weightiest part of the cathedral. Indeed, when I worked out the weight of one bay of Norwich Cathedral, the total weight was about 1,800 tons for one bay, of which about 1,000 tons was in the columns. So you can see how much weight went into the columns and the walls. Very little was in the stone vault at the top. Only about 3% of that weight I found in the thin stone vault. And this is the secret to success, keeping the weight light at the top, heavy at the bottom, to bring the centre of gravity down to a lower level. And then there's a stability element here. This arch allows these two columns to work together to form a stable whole, like standing on two legs instead of standing on one leg. And then you can repeat the exercise by putting more weight on the outside than on the inside. This makes this extremely steady and strong. I think it's possible to devise a kind of set of rules by which the stonemasons would have worked. For example, the slenderness ratio of a column. That is the height of the column divided by its width. And for most columns, if you keep that below 10, that's fine. Again, the arches and the vaults were proportioned with the set of rules. The thickness of a vault is roughly 1/20th of its span. So here at Norwich, with a span of about 10 metres, the vault is about 200 millimetres thick, and that works fine. So these are just some of the rules that the stonemasons would have passed on through the family line of father to son.
Worshipping in churches built partly by rule of thumb wasn't without the odd anxiety. The congregation of Beverley Minster in Yorkshire around 1213 grew uneasy at the new building works in their great church.
The craftsmen who were in charge of the work were concerned with beauty rather than strength. They let the new work into the old ingeniously but not firmly, in the manner of those who sew new cloth into old. At last it came about that from fear, a great part of the clergy and people refused to enter the church.
And there were occasional disasters. The central tower at Winchester Cathedral fell in 1107. One of the west towers at Gloucester collapsed in the later 12th century. At Norwich, the spire blew down in 1362. Many problems came from poor foundations, which caused the stones to slowly shift and crack.
Most people now think that the cathedrals were actually heavily over-engineered, and you could take quite a lot of stonework away from these buildings without them falling down.
In an upstairs room at York Minster, you can get a tantalising feel of the early stages of a master mason's work.
This is a very, very special place. These are the living quarters and the workshop of one of the top master masons in the country, the man who designed York Minster. Here, he might have come up with some of his best design ideas, perhaps sitting on his private toilet, which still exists over there. But it's not just a place for thinking and sleeping and eating. Here is his drawing board. His drawing board is the floor, and scribed on it are the individual lines, individual pieces of stone. And all around us are similar patterns, which over the years might have become quite a headache to work with. So every now and again, they had to put down a new layer of plaster, and to make it really firm, perhaps dozens of people, perhaps some of them children, would have come up here and walked around in socked feet. And you can still see the heels of medieval masons on this floor to this day, making sure it's as firm as possible for the next series of designs to be worked in.
There's a feel of the Mary Celeste about these marks, as if the master mason had just gone off for lunch. And the windows, built from this design, are still there, just a few feet away at the east end of the minster. The next task for the master mason was to choose the stone, up to 80,000 tons of it, dragged to the site by ox and cart, or floated downriver on barges from the quarries. This quarry supplies stone for Lincoln Cathedral.
It was a matter of bars, wedges, horses, carts, quite a labour-intensive process. They're naturally bedded. You can just see one going through there.
Oh, I see that flat line.
And there'll be another one down here and down here. So you've got 3 different beds. And they knew that, medieval masons knew the best stone. The best stone was the silver bed, which was the top one. The silver bed was top quality carving for your carvings, your caps, your angels, your grotesques. The next one was the lower silver, which was still nice to work, but a little bit softer. And then the red bed. They all had their individual usage.
Well, these are going to end up as beautiful carvings. You've got to have some pretty strict quality control, I imagine.
You have, even from the early stages of quarrying the block. If you see quite a few natural cracks in that, it is put to a waste pile. The quarrymen were quite good at their job because they wouldn't go to the trouble of getting it out if it wasn't any good anyway. But also, the final say was the master mason. It was hard labour, and especially all that work you went into to get them blocks out and then realise it had a crack in it. You know, it must have been so frustrating, so I do take my hat off to him.
The master mason then hired a team of stonemasons to work the roughly cut blocks. They followed templates made from his designs.
The templates apply to the outside of a block of stone, and they guide the masons. They show the masons what shape the stone should be, and if they follow the instructions on the templates and they follow the shape of it, they will end up with a block that's cut to the correct size. You may need several templates for one stone, depending on its complexity. If it's a very complex piece of tracery, for instance, or a springing stone, you would need a section mould, which would go on the side, that would give you the profile, a bed mould that would go to the top and apply to the bottom, probably 2 different moulds for that. And then you'd have to have a face mould that would show you the shape of the stone when viewed from the front, and any lines of moulding that are on there. It's almost like dressmaking. It's the same principle.
So this is the final destination of a piece of stone.
Yes, this one's come from the quarry. It's been worked, and we've cut a space for it to go in here. And we'll just put a little bed of mortar on here. This is just a mixture of sand and lime.
Medieval builders used lime mortar, which sets less rigidly than modern cement, so the stones could shift and settle over centuries.
Here I've got Lewis pins, which are very similar to ones that would have been used in medieval times. And I'll put this in the hole, and as I pull on them, they'll open up like so, and they'll grab hold of the stone for us. Yeah, if we can get it onto the edge.
And the stone below looks like it's from some previous restoration, but the one above has been there for probably about 600 years. And somebody presumably has had to come up here and do a very detailed measurement of that and create a template. And somebody down the mason's yard has used that template to come up with this lovely, clean, smooth bit of moulding here.
In cathedral building, ancient craft met modern assembly line. Each stone, individually designed and carved, then repeated to create symmetry and pattern. At Durham, the master mason prescribed the precise size and quantity of blocks he would need to build the church. The great zigzag and diamond patterns on the columns were created from 5 standardized designs: 850 blocks of one size, 600 of another, 230 of a third, and so on. By arranging these in different ways, all the patterns on the columns can be generated. It's as if the church was a vast jigsaw.
The building of a cathedral tested the skills and ingenuity of the cathedral builders to the limit. Yet, the ideas and methods that they used had barely changed since Roman times.
In fact, the style they built in the early period is called Romanesque. It's based on the kind of arch that the Romans used, the round arch. The shape was always based on a circle, often a full semicircle, sometimes a section of one, or with the curve slightly distorted. It was simple, but limited.
Arches in the style known as Romanesque can be sturdy, even chunky. A whole building made of these arches has a muscular, powerful effect. But in the middle of the 12th century came an idea that would change all this, a revolution in design and construction that would raise cathedral building to new levels of sophistication.
It was a style that would become known as Gothic. It was born in France at Saint-Denis, near Paris. Here, the visionary Abbot Suger rebuilt part of the abbey church, burial place of the French kings. He was using a new kind of arch. Not a round arch, but a pointed one. But his aims went beyond this.
For Abbot Suger had a vision. He wasn't simply after something bigger and grander. He had a theological rationale for his new design. It was a theology of light.
For medieval thinkers, light had a profoundly religious meaning. The embodiment of spirit, one writer called it.
The work should brighten our minds so they travel through the light to the true light of Christ. In seeing this light, the dull mind is resurrected from darkness.
Abbot Suger and his unnamed master mason had glimpsed the possibilities of the pointed arch. It's both stronger and more flexible than a round one. Both the shape and width of a pointed arch can be varied in more ways. And the weight of a building naturally moves downwards and outwards in a shallow curve, closer to that of a pointed than a round arch. This simple difference was to change the entire way cathedrals were conceived, designed, and built. The second Sunday in June 1144 may have had a greater effect on architecture than any other day in history. At the dedication service, bishops from all over Europe gathered at Saint-Denis to witness a building designed to evoke the experience of heaven more completely than anything before it.
The bishops were awestruck. They had seen the future. There was one dissenting voice. The monk Bernard of Clairvaux saw in such splendour nothing but worldly distraction.
O vanity of vanities, but more folly than vanity. Every part of the church shines, but the poor man is hungry. The walls are clothed in gold, while the children of the church remain naked.
But such asceticism was out of step with what the mighty bishops wanted.
England was the first country outside France to take up the new style. Lords and bishops had estates in France, and French was the language at court. When fire devastated the east end of Canterbury Cathedral, the most important church in the country, the monks here saw their chance.
The man in the 1170s chosen to be the new master mason was significantly a man who had worked for years in France. His name was William of Sens. His task, to create one of England's first Gothic cathedrals. The Gothic style started a push to build higher. It would place new demands on the unsung heroes of cathedral building, the carpenters. They built scaffolding and the timber frames around which entire sections of a cathedral were built, including the arches themselves.
We start off with a wooden centering, which we put in here. Then we just start off down the bottom of the arch, building the stones up either side. They're built on little pads which space it out nicely to give it a nice joint. And then once you've got to the top, you can put in the keystones and they'll wedge it all into place so that it won't move. After that, we pour lead into Y-shaped grooves that run down in between each of the stones, and that makes it even more solid. And then we finish off by putting mortar into the joints, pointing it up.
So putting up this wall is the final stage of the process?
Yes, once the wall's up around it, we can take the centering out and the arch will support itself.
And putting up arches like this is the basic building block of creating a cathedral.
Yeah, very much so. You can create very large spaces inside the building with much bigger arches than this. And it's the same technique that the medieval masons would have used.
Massive quantities of wood were required to build the cathedrals. Almost 1,500 trees had to be cut down to build Salisbury Cathedral. Often, the wood wasn't available locally and had to be sourced from abroad. Pine from the Baltic, oak from Ireland. Entire forests are locked up in the walls of the cathedrals.
And to get the great wooden beams and pieces of stone up from ground level, masons and carpenters used ropes, winches, pulleys, ladders, and the big Bertha of them all.
This is the windlass that the masons would have used to lift enormous blocks of stone to the upper levels of their construction site. By holding one of these pegs and turning this great wooden wheel, a mason could lift more than 10 times his own weight. As the wheel turned, this timber beam turned. And down here, you can see the gouge marks made by the ropes as they lifted the stones.
It was a precarious and a dangerous business. The spectacular east window of York Minster was designed by John Thornton of Coventry in the 15th century. It tells the story of the creation and the end of the world. Today, it's under repair, the conservators using much the same techniques as the medieval glaziers.
The starting point is a cartoon. The artist not only needs to draw in the detail on a plan or a cartoon, but also needs to tell the glass cutter where to cut the glass. In the medieval times when this panel was being made, the dark lines would have indicated where to cut. So you need to cut glass first. The glass could be brought in from the continent, we think possibly from France or the Low Countries, because they were making the best quality of glass at that time. The impurities in the materials that make up the glass tend to give it a very beautiful tint of greenish or yellowish, and so the border pieces are all a tinted glass. But if you look inside, you can see different colour glasses, red glass, blue glass. Well, that would be brought in as blue glass, but at the molten stage, oxides would be added, and in this case cobalt would be added to the melting pot to make that glass blue. The rough shapes would have been laid out and then finely glazed by just nibbling away at the edges with the bar. Once the glass was then laid on the sheet, the painter could begin the work.
Then the glass was joined together using strips of lead. When it was put in place, it was perhaps the largest stained glass window in Europe.